Muchas gracias por la introducción. El trabajo que voy a presentar es un trabajo realizado por Lina López Ricaurte para su tesis doctoral, pero ya no lo podía presentar y lo haré yo en su lugar. As a deference to our international speakers, I will give my talk in English. I will try to put my presentation, just a moment. Okay. Okay, you can see my presentation, I think. So I'm going to talk about how the location of the breeding colony and the climate shape the timing of pre-breeding migration arrival in lesser kestrel. As I tell, this is a work by Lina López Ricaurte and a lot of other authors that have contributed with data or with analysis. And so we will start about this. So in general, it's accepted that species have a certain urgency to arrive to the breeding areas. Why? Because, nesting sites are limited. And so you can expect that there would be a competition for acquiring a good nesting site or a good nesting territory and also getting a mate. Especially in the case of raptors, males are the ones who tend to select the nesting site and are selected by females. So we would expect that males have a greater urgency to arrive from migration. We can distinguish between what we call proximate causes and ultimate causes for a certain behavior. In relation, what are proximate causes? Well, proximate causes are the direct factors that cause the behavior. So we would consider, in the case of the migration arrival, how do kestrels arrive on a certain date to their colonies? But ultimate causes are the ones that have promoted that behavior. So how did that behavior evolve? So why do kestrels arrive in a certain date and not in others? Considering proximate causes, we can think about if you want to arrive early, you should depart early, but you could also just travel fast, or you can just reduce the number of stops. Considering what we call ultimate causes, migration arrival could be just determined by the conditions at the wintering site. So for example, if the conditions at the wintering site deteriorate, there is a reduction in food or the weather is worse, then the kestrels or the individuals may be forced to start migration. Also, arrival could be just determined by the conditions found en route. So if the migration is difficult and the birds have to suffer unfavorable weather or perhaps have to cross difficult barriers, then arrival could just be determined by what they are facing during their migration trip. At the end, arrival could be just determined by what you are expecting at destination. So you might just decide when to leave, how fast to travel, and how much to stop, depending on when do you want to arrive. So we think that, well, the ultimate cause would be trying to arrive at the optimal time to your breeding territory. Which are the methods that we have used for this work? Well, we have 61 lesser kestrels, data from 61 lesser kestrels out of 73 that were tagged using GPS loggers. These are loggers that can be downloaded from a base using VHF radio frequency. They have been used. We have used loggers from different manufacturers: Microsensory, PathTrack, and Ecotone. And they were marked at 33 breeding sites in Spain and Italy. The period from this data are from 2016 to 2021. And at the end, we recovered 84 pre-breeding migratory trips. The number of migratory trips is greater than the number of kestrels because many of the kestrels were able to provide data for at least 2 or even 3. The case of one kestrel, we were able to get data from 3 pre-breeding migratory trips. This is thanks to the many participants that have worked on this study. So it has been coordinated, the analysis by EBT CSIC, so Doñana Biological Station, but data come also from SEO BirdLife, Terra Naturali, and ISPRA, University of Milan and University of Palermo have provided data, and funding has come from the different projects, Junta de Extremadura, also, GREFA has provided data, and funding come, in the case of Spain, mainly from program Migra, funded by Iberdrola, but also by different live projects like Live Cepa Urban that provided the data from Extremadura, and also on Falco Peramico provided the data, many of the data from Italy. So the first thing is to say, well, is there a variability in arrival date? Do the birds arrive all at the same time, or there is a strong variability? And the answer to that is yes. There is a relatively large range of arrival dates that go from the 2nd of February to 13th month. So there is almost 3 months in which the birds could arrive to their colony. The fact is that is not only that you can travel faster, that you will arrive the first. So we know from the tails. So which are the different the contributions to this early arrival from departure date, migration speed, and stopover time? Because you could, to arrive early, you could just leave early, but you could just speed up during your travel, or you could reduce the number of stops. What we have done is try to model all this from the data we have. And we can see here in these graphs, you can see the day of arrival on the y-axis. It's expressed as day of year, so DOI, arrival DOI. It's the number of days from January the 1st. And you can see that departure date, so departure DOI, is the main factor that explains the arrival date. So if you want to arrive early, you should depart early from your winter destination, wintering sites. In these graphs, you can see we have separated the northern colonies from the northern colonies in black from the southernmost colonies in blue, to see if there were any differences related to latitude. But in general, you see it's a similar pattern. Also, stopover, the number of days that the birds stop during migration has an influence on arrival day. So the longer you stop, the later you will arrive. Also, you can see that speed has some influence, but it's much less. So we would say 80% of the variance is explained by departure day. 40–50% is explained by stopovers, and only 20% is approximately explained by speed, migration speed. Here you can see the same information in different models. So this is just fitting a generalized linear mixed model in which we take into consideration that some of the data come from the same birds in different migratory trips. The data have been modeled as standard deviation units. So you can see that the estimate gives you an idea of the relative importance of each factor. So here we can see the similar thing. So departure date is the main factor, followed by stopover days, and while speed has a relatively minor role in arrival date. So we see departing early is really the most important thing if you want to arrive early. So which is the variability in departure date, and here we can see it. So the different lines show you the latitude distribution or movement of the different birds in relation to date. You can see in blue the ones arriving to southern colonies, in black the ones arriving to northern colonies. And you can see that the migration departure extends from February up to May. Is a little bit more reduced in the southern colonies than in the northern colonies. So if you want, what is more important for departure day, where you are or where you want to go? So the thing is, the departure date is influenced by the place where the birds are. So what they are experiencing at that time, or it's mainly influenced by the place where they want to go, what they will expect to experience at that time. And what we see in this model, we are just modeling this in relation to arrival latitude or longitude, or departure latitude and longitude, is that the place of departure has very little influence, no significant influence, while the place of arrival has a very strong influence. We can see this on a map, and here we have plot for each colony, the mean the mean departure date. So this is the number 69, for example, this would be 69 days after the 1st of January, and indicates the more red colonies are the ones that arrive later, the more white ones are the ones that arrive earlier. So you can see there is a spatial pattern that goes from southwest to northeast. So the first birds to depart from Africa are the ones that from the southwestern colonies in Spain, so Andalusia, Doñana, and the last birds to arrive are those from Alta Murgia and Gravina in the south. It's South Italy, but it's the northeastern part of the range we have studied. If we model this in relation to weather or climate conditions, what we find is that there is very little influence of the conditions the birds are experiencing in Africa, but a good predictor is the temperature that they have the colony in March. So climate conditions at the Destiny colony are really relevant to determine the departure date in Africa. We can see here, we have plotted the temperatures, mean maximum temperatures in March. And you can see more or less they follow the similar pattern. So the ones in the north of Spain and the ones in southeastern Italy are the ones that have the lower temperatures, and are also at the same time the ones that arrived later. So here you can see that lesser kestrel decide departure date in relation to the temperatures they are expecting to find at the colonies where they are migrating. Here in the graph, you can see the mean maximum temperature in March and the day of migration onset or the day of migration departure from the wintering sites. So on the right, you can see that the places that have the higher temperatures in March are the ones in which birds depart earlier, while the ones that have the lower temperatures in March are the ones that will depart later. What about stopovers? So in the graph on the left, you can see the distribution of stopovers. So we have birds that do not stop during migration. Approximately 1/3 of the trips are of birds that don't stop, go in just in one go. And at the same time, we have birds that stop in a variable number of days that go from 1 up to 25 days during migration. There is also a relation between the length of stopovers and the temperature at the colony of destination, but this relation is not as strong as departure date. Is marginally significant, but it explains only 3% of the variance. At the same, you can see a similar pattern. So the birds from the colonies in the south of Spain that have higher temperatures in March will stop less than the birds from Gravina and Alta Murgia that go to colonies in East Italy, where the temperatures in March are much lower. Here we saw this, but in a different way. So we are just plotting the trips of the northernmost colonies and the southernmost colonies. and indicating with different circles of different size where the stopovers are located and the size, the length of these stopovers. You can see in general that birds that are southern breeders will stop less, while the birds that are northern breeders will stop more and make longer stops. This is also shown in the boxes below. So, and we are also trying to check if there were any differences between males and females. And you can see that although there is a difference between the northern breeder and the southern breeders, there is very little difference or hardly any difference between males and females. What about migration speed? Well, there is no significant relationship between migration speed with March temperature, neither with colony location. So the migration speed is also quite variable. It can range from 100 kilometers per day to up to 600 kilometers per day. So it's nearly sixfold. But this migratory speed is mainly influenced by wind speed and direction, and apparently is not something that the kestrels can select. So to conclude, we can say that there is almost 3 months difference in pre-breeding spring migration arrival at the lesser kestrel colonies. Arrival date of lesser kestrel pre-breeding migration is mainly influenced by departure date and stopover duration, while the speed migration has only a minor influence on arrival date. Kestrels depart from Africa depart date from Africa will depend on the breeding colony to which they want to arrive, following a southwest to northeast gradient, and not really influenced by their wintering locations. The kestrels will depart from the Sahel and extend stopover duration depending on the temperature they are expecting at the colony at the time of arrival. Migration speed is influenced by wind and speed direction, but not really influenced by the colony the birds want to arrive. And although males should have a more urgency, we haven't been able to find any sexual differences in arrival date. So at the end, males and females arrive approximately at the same time. So thank you very much for your attention.
Muchísimas gracias, Javier, por la ponencia, y vamos a ver si hubiera alguna pregunta para este tema.
No hay ninguna pregunta. Muchas gracias.
Muy bien, pues muchísimas gracias, Javier.